Auzubillahiminashaitanirrajim. Bismillahirrahmanirrahim. Here we go with the third part of our basic definitions that have been continued like since last two videos. So in previous videos, we have already discussed about the basic definitions that we come across in our daily life when we are talking about chemistry. That is elements, compounds, mixtures, atomic number, mass number, or isotopes. Now we are moving towards the next topic, that is a relative atomic mass. That is something definitely new. That is anything which is like relative to a certain quantity or relative to a certain standard unit. So in relative atomic mass, before going into the detail of the definition, first of all, I would like to draw your attention towards this physical valence I have written here, made here. That is showing two pans, left hand side and the right hand side. So in left hand side pan, you can see there is vegetables being weighed, and on right hand side you can see there is a standard 1 kg stone which is present, or at least that is imagined. So when we have to weigh the vegetables against a certain mass, we definitely have to have a standard unit. For this instance, if I'm taking 1 kg stone on right hand side pan, that means I am having a standard mass that is known to be exactly equal to 1 kg. So on left hand side, I'm just about to add in vegetables, and until both the pans get a balanced state, or both the pans get in an equilibrium, that both hand sides are just equal in weights. So that's why finally, when is the last vegetable put into the left hand side pan, and this has got to be equal or balanced or in equilibrium, now we can say that the weight of vegetables on left hand side is exactly equal to the stone of 1 kg present on right hand side. So that's why we are weighing this pan, or we are weighing these vegetables against a standard unit, and that standard unit is found to be exactly 1 kg. So by taking that example, I can say that both sides are balanced, so mass of vegetables is equal to 1 kg. So mass of vegetables is relative. Why? Because it is compared to 1 kg, which is a standard unit. So 1 kg stone we are taking as a standard is called as unit or a standard unit, while the thing we are going to weigh is having a relative mass relative to or related to the 1 kg stone present on the other side. So coming to the example, we have the mass of an atom of an element relative to the mass of an atom of carbon-12. It's called as relative atomic mass. Here we are, just like in case of vegetables, we took standard stone of 1 kg as a standard unit. Same like that in upcoming examples, we will be taking carbon-12 as a standard unit, and against this standard unit we are going to weigh, or we are going to find the mass of other atoms. How is it? So I'm going into the detail and we'll be coming back to the first definition. Now we have got the example of like physical valence, but now the question is, can we find the mass of one single atom using this valence? Answer is no. Why? Because a single atom is so small that how many atoms you are going to add on this left hand side to weigh is equal to 1 kg. So we all know that atom is so small that we cannot even see with naked eye. We definitely need to have different instruments to see that atom. So how is it possible that we are adding so many atoms to the point or to the extent that may equal a weight or stone of 1 kg? So it is not possible. Now what will happen? Consider a single atom of carbon-12. Why I'm reading it as carbon-12? We don't have to call it as 12 carbon, because I am not talking about 12 atoms of carbon. Rather, I'm saying at carbon-12. What is meant by carbon-12? Because mass of carbon is 12 units. How? Protons is equal to 6 and neutrons is equal to 7. So atomic mass of carbon is equal to 12 units. You can say C12, carbon 12, means 12 is the number that is coming from its atomic mass. So a carbon that is existing on Earth with atomic mass is equal to 12, called as carbon 12. Okay, here one more thing I need to mention is about isotopes. We had studied about it earlier, that there are different elements which are present in the universe in the form of isotopes, and in the form of isotopes, I repeat, there are same number of protons but different number of neutrons. So carbon also exists in its isotopic forms, but carbon having 6 neutrons along with 6 protons is most abundantly present type of carbon isotope. So what we are using as a standard, which is normally commonly found in the universe, that is carbon having 6 neutrons and 6 protons makes up carbon 12. So this carbon 12 is equal to proton is equal to 6, neutron is equal to 6. So that's why we call it as carbon 12. Now, we are taking the example of this carbon 12 as a standard because this is something scientists have already found about its atomic mass individually. So coming back to the physical balance example, if I place carbon 12 on both sides, the balance is in equilibrium, right? Why? Because on both sides mass number is equal to 12. Just like if I'm putting 1 kg stone on left hand side, 1 kg stone on right hand side, definitely the physical balance will be in equilibrium because on both the sides weight is equal. Same like that, in case of carbon 12, we have put the same atom on both sides, so it is in equilibrium. Now, consider if I cut or divide this carbon atom into 12 equal parts or 12 equal units. Is the balance still in equilibrium? The answer is yes. Why? Because all these single units still make up one carbon atom. So these single units you can see are basically like 6 protons and 6 neutrons. So if I'm even dividing it into a single structures or into units, that as a whole is the mass that is equal to one single atom of carbon 12. I repeat, mass of one carbon atom is equal to 12 units. So it is the balance you can see is in perfect equilibrium. So carbon 12 one atom is equal to its 12 units. Now we shall use small units of carbon or 12 units of carbon as standard units to measure the masses of other atoms. For example, if we are putting the same 12 units of carbon atoms on right hand side, just like in previous example we had put right here. Okay, so these are the same 12 units of carbon atom we have put on the right hand side pan of this equilibrium, and we have replaced carbon 12 with oxygen atom. Now when we have replaced this oxygen atom, for example, we had used carbon, and in that case carbon was carbon 12 and this is carbon 16. Here you can see we have what? We have carbon 16. And what is meant by carbon 16 here? That these are something, or this is a type of oxygen you can see here, which is having different number of protons and neutrons. As in previous example or in a previous slide, we had observed that carbon 12, that means total number or mass number of carbon was 12. Here we can see that we have oxygen whose mass number is 16. So is it possible that this thing is equal to this thing? The answer is no. Why is it so? Because right now we do not know anything about this oxygen atom. Like we are not sure about this oxygen atom, that how many atomic mass or how much this single oxygen atom weighs. So when scientists put one oxygen atom in front of 12 units of carbon, they observed that oxygen got to be heavier. Although this is not something that is done in terms of physical balance, but it is just something to explain it to you, that if I'm putting oxygen on left hand side and 12 units of carbon on right hand side, the oxygen pan is heavier. That means we have to add in more carbon units on the right hand side so that this physical balance can get into equilibrium. Now what will happen? Now we added, like you can see, we had already previously added like 12 units were there previously. Now I have it 1, 2, 3 and 4, and 4 units if added more on right hand side, this span perfectly is equal to the left hand side pan, which is having one oxygen atom. So what if we add 4 more units to right pan? Mass of single oxygen atom becomes equal to 16 units of carbon. Now you can see mass of one single oxygen atom is equal to 16 units of carbon because we had to add 4 more to 12 to get it to 16. Now coming back to the example, definition we talked about in the previous section was the mass of an atom of an element relative to the mass of an atom of carbon-12 is called its relative atomic mass. So in case of oxygen, we had to put 12 plus 4 units of carbon atoms to get exactly 16 units of oxygen. So with reference to carbon units, we had got what? We have got the atomic mass of oxygen, that is found to be 16 with reference to carbon units. So now it is called as relative atomic mass. Relative to what? Carbon-12. Here you can see we have like atomic mass unit for everything which is present in around us in a form of magnitude. It definitely has to be shown in terms of some units. Like to weigh something, we have to add like kgs, grams, micrograms, and if we are talking about temperature, we have to say along with the like 36 degrees Fahrenheit, 30 degree Celsius. So that is something that we need to add the unit to express a term. Same like that when I'm talking about atomic mass, that is not something that can be weighed in kilograms, grams or micrograms even. So it is so small that it has to be weighed in terms of its specific unit called as AMU or atomic mass unit. So now we know that mass of single oxygen atom is equal to 16 units of carbon. So we call this as relative atomic mass of oxygen because it is measured against carbon units. But what is AMU? Again, consider a previous example. Mass of carbon-12 is equal to 12 units. Now if I take only 1 unit out of these 12 units, then I have got 1 atomic mass unit or 1 AMU. Considering only 1 unit of these 12 units, 1 unit is equal to 1 AMU. Then 12 units are going to be equal to 12 AMU. So 1 AMU is actually 1/12th part of carbon atom. Considering the example of oxygen once again, we have got that mass of one oxygen atom is equal to 16 units of carbon atom. Now we can say that relative atomic mass of oxygen is equal to 16 AMU because 1 unit of carbon atom is equal to 1 AMU, then 16 units of carbon atom is equal to 16 AMU. Similarly, we have got other examples like sodium, that is 23 AMU, and chlorine, which is having 36 or sometimes 35.5 AMU. So that was the end of the atomic mass and its unit. Thank you.